Okay, so here's number 2. They tell us that BC is, well, that's what we're looking for. We're looking for BC, but they tell us this angle right here is 160. So we're 20 degrees short, right? I don't know if I can fit 20 in there. Let me zoom in on this guy right here. We're 20 degrees short of 180. So there's 20 degrees right in here, right? Let me put a 20 out here. It doesn't show up very well in there. So BC is 20 degrees. All right, so 20 degrees. On number 3, let's look over here at number 3. The key is you got to draw in a radius to y. So this is also a radius, like AB was a radius. AB is 6 long, so AY is 6 long. And then AC is 4 long. And we're looking for CY, so let me put an X right here. So I'm going to go X squared plus 4 squared equals 6 squared. And I get X squared plus 16 equals 36. I subtract 16 from both sides, and I get X squared equals 20. And then I take the square root of 20. Now I said to people, this is probably going to be a 5 out of 5. You can simplify, you get a 6 out of 6. So that's the square root of 4 times 5. And the square root of 4 is 2. So I get 2 square root of 5. So right over here, 2 square root of 5. This is the Pythagorean theorem, right? You got to use that on problem 3. Problem 4, if this is 100 degrees, this is 80 degrees. And a vertex on the circle right here is half of the intercepted arc. So this has to be 40 degrees right over here. So that is this one right here, 40 degrees. And then same with this guy. We're looking for this angle. See how it's half of this arc right over here? That arc is 180 degrees because this is a diameter. So this is 90 degrees right there. All right, on this one, it's a Pythagorean triple because we have a right angle here. When you have a tangent drawn to a radius, it's a right angle. This side over here is 13 long. So it's a 5, 12, 13 triangle. No work needed on a Pythagorean triple, right? Let's see. Oh, by the way, these are similar problems on that Alex practice test. So I would suggest you try some of the similar problems over there. Number 6, we're going to convert angle BAC to radians. You can see that it says 60 degrees right there. So what you can do is you can go 60 out of 180. That reduces down to 1/3. So we're going 1/3 of the way over to pi. If we went the whole way, this would be pi right over here, right? But we only want to go 1/3 of the way. So you could go 1/3 pi, or you could write that as pi over 3. Then it says this over here, let me change to blue. This over here is 2 pi thirds, right? That's what this is saying right here. That is the length. See, it says the length of BD, 2 pi thirds. That's the radian measure. They're telling us just flat out what the answer is to this question. That's the radian measure because the radian measure is the length of the arc, right? Now we got to get to this angle right in here. What's the measure of this angle? Well, if this is 60, this is 120 degrees. So you don't really need to convert from radians to degrees here. If you just look right over here in the drawing, this is a 180 degree angle, right? All right, number 7, the vertex is outside the circle. So this angle is going to be half the difference of these two arcs. So like X and Y, we want to go 1/2 of X minus Y, right? And it tells us the X is 100 over here. The Y is 80 over here. So if I go 100 minus 80 and I do half of that, I end up with 1/2 of 20 or 10 degrees. So number 7 is 10 degrees. Number 8, vertex is outside the circle. So this angle is half of 80 minus X. So let me put that down. 1/2 of 80 minus X is equal to 30. Hey, if this is going to be 30, the number in here needs to be 60 because we want 1/2 of 60 to generate 30, right? So what do I need to put right here to make 60 after we subtract, right? Well, that would have to be a 20. That's called a look inside technique. 80 minus 20 gives us 60, right? So DC needs to be 20. You could solve this algebraically. You could multiply both sides by 2, subtract 80, divide by -1. But it's way easier just to look inside, say, hey, what does this angle need to be? BD is inside the circle, so it's equal to half the sum of the two intercepted arcs, right? So that's got to equal 40. So think about it just like we did up above. What needs to be right in here? So when I take half of it, it gives me 40. Well, it needs to be 80, right? Half of 80 is 40. So what would have to be sitting right there to generate 80 all together? Like what plus 70 is 80? 10. So 10 plus 70 gives me the 80, right? I hope I made that all clear. After break, if you want to take the test, that'd be fantastic.